A list is a collection of elements of various types which are enclosed within a pair of square brackets and separated by comma. Remember, a list is a sequential data structure in Python, which means we can index a list using integer values, and we can also slice lists like we saw for strings. Now the question is, how would you create a list? So let's get started. So in order to create a list, what we do is we'll have to first come up with a name of the list. Let's start by creating an empty list. So let's say we come up with the name of the list. Let's call it my underscore list. And let's say we want to create an empty list. So what do? We assign it to a pair of empty square brackets. So on assigning it to a pair of empty square brackets, what happens is an empty list gets created, right? So this is how you write a comment in Python. I hope all of you remember this. So if I execute this cell, then what happens? Let's see. So if I execute this by pressing Shift Enter, I see that a new list has been created. Now, how do we verify this, whether the list has been created or not? Let's check the type. So if we pass my underscore list to the type function, what do we find? We find that the output is a list, which proves that yes, my underscore list is indeed a list and it has been created successfully. Now, the fact that this is an empty list can be verified by the length function. So just like for strings, we had the len function, we also have the len function for lists. So if I want to find the length of a list, if I want to find the number of elements present in the list, what I do is I simply pass the name of the list to the len function. And as you can see, I get the length of the list as 0 because it's quite rightly an empty list. So this is how you can create an empty list. Now, how about creating a list with elements? Let's go about it. So again, you have to come up with a name of the list. Now let's call this football, and you assign it to a pair of square brackets, and within the pair of square brackets you can assign values. So let's say I write the names of a few football players. Let's write Messi, let's bring in Beckham, and let's bring in Kane. Okay, now if we execute this, we can see that the execution is successful. Now if we try to find the length of this list, what should we get? We should get 4, right? So let's verify this. Yes, we get 4. So this is how we create a list containing strings, right? So similarly, you can create a list containing integers, or you can create a list containing floating point values. Now remember, list is a heterogeneous data structure. So I'll just type this out for you. Remember, a list, so list is heterogeneous in nature. Okay, I think I missed a space there. Sorry about that. So list is heterogeneous in nature. I hope I got the spelling right. Yeah. Now, what does this mean? The fact that a list is heterogeneous in nature, what does it mean? It means that a list can contain elements which are of different types. Although we do not find this too much in application, we generally will create lists having elements of the same type, but oftentimes it may be required that you build a list which contains elements of different type. Now, it's possible. With lists in Python, it is possible to have elements of different type. That's why list is called heterogeneous in nature. Now let's see an example of this. Let's say I'll just call this random underscore list because this is going to be completely random. I'm going to come up with random values here. So let's say I have an integer value, let's say 123. I have a string, let's call it Python, and let's say I have a floating point value, something like 3.14159. And if I execute this, you can see that the execution is successful. And not only that, if I try to find the length of this list, I think I'll be successful. So if I, yeah, there you have it. The length is 3. So that is how we can go about creating lists. So firstly, we saw how to create an empty list. Then we went on to see how we can create a list of strings. That means a list of elements of the same type. So similarly, you can create elements in a list which are integers or floating point values. And you can also have a list containing elements of different type, like we saw in case of random list. Okay, now let's see how we can index list. Remember, a list is a sequential data structure. Again, let me type this out for you so that things are in perspective. So remember, lists are sequential in nature. Okay, or let's put it this way, lists are sequential data structures. Okay, structures, am I getting the spelling wrong? I think I have corrected myself now. Yeah, so lists are sequential data structures. Now what does this mean? It means that the elements in a list, okay, the elements in the list can be accessed using indexing and also slicing. So we'll see indexing and slicing separately. Let's start with indexing first. Remember, a list is called a sequential data structure because it can be indexed using integer values, which includes both positive as well as negative integers. And we can also go ahead and slice lists, just like we saw in our earlier lectures on strings, where we went ahead and sliced strings. We can also go ahead and slice lists. So let's see how we can index lists. So let's take a few examples. So we have a few lists created already, right? So we have football and random underscore list. So let's bring those back. So if I just try to print my football list, so this is what I have, right? Okay. Now, what if I try to find this particular item in the list, Messi? What if I want to extract this value? So what do I do? Very simple. You first write the name of the list. What is the name of the list? It's football. Now, within the pair of square brackets, you specify the index value of the item. So remember, every list item has a positive index value as well as a negative index value. So positive indexing starts from 0. That means Ronaldo has an index value, a positive index value of 0. Although some of you may argue that no, 0 is a different number, like it's something which is separate by itself. So we can classify numbers into we can classify numbers into three types. We can classify them as positive numbers, negative numbers, and 0. Yes, I agree. That is one argument. But just for the sake of simplicity, I'm assuming 0 to be a positive number here. So Ronaldo is at index 0, Messi is at index 1, Beckham is at index 2, and Kane is at index 3. Because indexing, remember, the positive indexing part, the left to right indexing part in lists always starts from 0. So you start from 0, 1, 2, 3, right? And how about negative indexing? Exactly the same as it was in case of strings, right? We have seen all this in strings. We saw indexing in strings. It's the same in lists. Okay, so how about negative indexing? It's the same thing. So Kane, which is my last list item in this case, in the list football, Kane is at a negative index of -1. Beckham is at a negative index of -2. Messi is at -3 and Ronaldo is at -4. Okay, so you can extract this particular list item called Messi in two ways. You can either go with positive indexing or you can go with negative indexing. I'll show you both. So if I do football and within square brackets, so football is the name of the list. Now within square brackets, if I pass the index value of the item that I want, which in this case is Messi, I'll get it. So if I say 1, if I execute this, there you have it. I have Messi with me. Now, how about negative indexing? So Messi is at a positive index of 1 and it is at a negative index of how much? Kane is at -1, Beckham -2, and Messi is at -3. So if I try to print, so if I say football of -3, let's see what I get. Perfect, I get Messi again. So there you have it. You can index lists using both positive integers as well as negative integers. Okay. And remember, lists are ordered data structures. So let me again put this into perspective. So remember, lists are ordered. Okay. Lists are ordered. That means if I create a list, so if you remember, this is the list that I created originally. Let's go back. Yeah. So this was the ordering of the list items, right? For the list football. So it was Ronaldo followed by Messi, followed by Beckham, followed by Kane. Now that list ordering is preserved. So when I printed my list, when I printed the complete list football, the list items are preserved. right? The ordering of the list items is preserved. So it's Ronaldo followed by Messi, followed by Beckham, followed by Kane. Now, this is not always the case. Okay, there will be a few data structures where the ordering does not get preserved. I'll give you two examples. One is the set data structure. We'll look at set later on. So the set data structure will not preserve the ordering of the list items. That means ordering is not guaranteed. Okay, so it may happen that ordering is preserved in set, but it may also happen that the ordering does not get preserved. So it's something that you cannot predict beforehand. For list, you can clearly say that, okay, if I create the list in this particular order, then if I print my list, every time I'll get the same order in which I had created my list items. Okay, the order in which I had placed the list items in my list, that ordering will get preserved every time I access the list, every time I print the list. Okay, so that is possible in a list, but for a data structure like set, that is not guaranteed. So there may be cases where the items in a set are not printed in the way in which they were created. Okay, same is the case with dictionaries. Okay, there is another data structure called dictionary, although dictionary operates in a completely different manner as compared to lists and sets. However, even in case of dictionary, the order in which we create our dictionary items, that ordering is not guaranteed to be preserved. Okay, all right, so let's move ahead. Let's look at slicing. So what is slicing? So slicing in a list, or slicing a list, means, extracting a particular portion from the list. So if I just bring back let's say I bring back, now I want to work on random underscore list. I think that was the name of the list which I had created. Yeah, random underscore list. So if I want to just work with this list now to demonstrate slicing, I can do that. So I'll just say print random underscore list. Yeah, there you have it. Although this is kind of a small list, so I would want something which has a few more items. Okay, let me create a new list altogether. Let me call it new list itself. Okay, so I'll just insert in a few values. I'll say 1, 2, 3, 100, 240, let's say 56, 100, and 290. And I'm just coming up with just random values. Okay, there's no logic behind this. I'll just execute this. Okay, so I have quite a few values now in my new underscore list. Now I want to show you what slicing is. So once again, I know I'm bringing this back over and over again, but the concept of slicing, you can relate it to strings as well. Okay, the concept of slicing, which we saw in strings, also applies in case of lists. Now, what do we do in slicing? If you can recollect, in slicing, we extract a portion of the list. Okay, so we extract a portion of our data structure on which we are performing the slicing operation. Here we are performing the slicing operation on a list called new underscore list. That means we want to extract, or we want to take out a certain portion of the list. So it's like slicing a birthday cake, right? So you have this huge cake. Now from there, you take out a slice. That means you take out a portion of the cake. So it's the same thing with lists. You take out a portion of the list. You extract, let's say you want to extract this portion, 100 to 56. So you can do that. Okay. But remember, slicing will not alter the original list. Okay, so even if I'm extracting out 100, 240, and 56 from new underscore list, that doesn't mean that new underscore list will get altered. It will remain as it is. Okay, so slicing does not alter the original list. So the list on which you are performing the slicing operation will not get changed. Please keep this point in mind. So let's say I want to print the slicing operation result directly. So I'll just pass the slicing result to my print function. I'll say new underscore list. Don't worry, I'll give you the general syntax for slicing in just a while, but let's take a few examples. So I want to start the slicing from 100. So what is the index at which 100 belongs? So I'll deal only with positive indexing because it's easier that way. So 1 is at index 0, 2 is at index 1, 3 is at index 2, and 100 is at index 3. So I'll start from 3. I'll give a colon. And where do I want to stop? So this is 3, 240 is at 4, 56 is at 5. So you might be wondering that maybe I'll stop at 5 then, because the last element that I want, which is 56, in this case, for new underscore list, is at index 5. But here is where we'll have to be careful. Remember, slicing is inclusive of the starting index, which in this case I have specified as 3, but it is exclusive of the ending index. That means if I specify it as 5, then it will go not up till 5, but up till 5 minus 1. That means it will go up to but not including the ending index. So in this case, it would go up to 4, not up to 5. So in order to overcome this, what we do is we always go for a value which is one more than the index of the element which is right at the end of the slice that we want to extract. So what is the element, or which is the element at the end of the slice which we want to extract here? The element is 56. And what is the index of 56? The index of 56 is 5. So we'll have to go 5 plus 1. That means we'll have to go till 6. Okay. And we can give a colon and we can specify 1. So here 1 denotes the step count. That means what is the interval at which you're extracting the value. So you're starting from index 3, which is you're extracting 100. Then you will increment by 1. So you'll go to the next element, which is 240. You will extract it. Then you will increment again by the step count, which is 1. So you'll extract 56. Then you realize that you have come to an end of the slicing operation and you stop. So if we execute this, let's see, there you have it. So it's exactly what we were expecting. And that is the slice. Now, even after the slice, if you print new underscore list, this is the point I was trying to make. See, my new underscore list is unaltered. Although I have performed a slicing operation, the original list on which the slicing was performed is unaltered, right? Okay, now let's show you the general syntax of the slice. So if you want to perform the slicing, then it's like this. So I'll just add a line break. So in order to add a line break for markdown cell, you use the BR tag from HTML. So here what we do is we say for slicing, we first specify the start index. So I say start underscore, or let's just give a space, start underscore index. We give a colon. Then we specify stop index. Okay. So of course, this stop index means the index value of the element that you want to extract, which is at the end, plus 1. Okay, so like here we saw the index value of the element which we wanted to extract last was 56, right? So the index value of 56 was 5, so we went 5 plus 1. So here stop index is that last index plus 1. Okay, and give a colon and then you give the step size. Okay, then you give the step size. So this is the general syntax. This is the general syntax for slicing. Okay, now of course you can experiment with this. Let's perform a few more slicing operations. So if I say, I'll show you a few interesting things. You might be surprised to know that start index, stop index, as well as step size, all these three values, all these three parameters that we need to specify for slicing, they are actually optional. That means if I simply say colon colon, that means I do not specify anything. I get back the original list entirely. Okay, I get back the original list entirely, right? Okay, so this is if you don't specify any value. So if you don't specify any value, so here I've not specified the start index. So what is the default in that case? So if I don't specify the start index, what does the slicing operation assume it to be? The slicing operation assumes the start index to be 0. So the slicing begins from the first index. Now, if we don't specify the stop index, what does the slicing operation assume it to be? The slicing operation assumes it to be till the last element. That means it is inclusive of the last element. So whatever is the index of the last element plus 1 will be my stop index if I do not specify it explicitly, right? And how about the step size? If I do not specify it, by default, it assumes it to be 1. Okay, now let's try to experiment a bit more. let's say we do new underscore list, and let's say we omit the start index. That means it will always start from 0. And let's say I give a random value 4, and I omit the step size as well. And if I execute this, now can you see? So it starts from index 0. That means it prints 1, then it prints 2, then 3, then 100. That means up to index 3. And then it stops, because what is my stop index? My stop index is 4. So it will go up to but not including 4. That means it will go till 3. It will go till 3, right? Okay. Now let's take up another example. So let's say print new underscore list. Okay, I think I should print out new underscore list once again, so that you have it in mind. You can see it what it originally is. Otherwise you kind of lose focus on it. Now let's try to omit the stop index. So let's say I say the start index is 3. So if I say the start index is 3, that means I'm referring to the value 100. So the printing should start from 100, because it is inclusive of the start index. And let's say I do not specify the stop index. I do not specify the step size. If I execute this, there you have it. Starting from 100, it will print all the elements till the end of the list. Okay, this is what happens when you don't specify the stop index. Now, how about we do something like this? So if we say new underscore list, we don't specify the start index, we don't specify the stop index, we only specify the step size, and we say the step size is 2. Then what happens? In that case, it will start from, so what is the default for start index? It's 0. So it starts from the very first index and prints the value 1, and then it increments in terms of 2. So the step size is 2. So after 1, it skips 2, it skips the second element, and then it goes to the next element. Then again it skips one element, it skips 100 and prints 240. Then it skips 56 and prints 290. And then it skips 134, but there are no more elements left, so there's nothing more to be printed, and that is the final output. Okay, so this is what happens when you omit either the start index, the stop index, or the step size. Okay, these are the various possibilities that you get. Of course, you can experiment more with these. You can do something like this as well. Let me show you one more example. So you can have, let's say, the start index is 2. You don't specify the stop index, you specify the step size. How interesting is that? Let's see. There you have it. So you start from index 2. That means you start from 3. You start from the element 3, because element 3 is at index 2, right? You'll always start from the index which is specified, the start index. In this case, the start index is specified as 2. So you will start printing the element 3. Then you jump in terms of 2. So you skip 100, you print 240. You skip 56, you print 290. You skip 134, there's nothing else to print. So you get these 3 elements as the output. Okay, so let's quickly recap what we have learned in this video. We started off with what exactly a list is. We defined a list. Then we went on to creating a list. We saw 3 ways or 3 types of lists that we created. We saw an empty list. We verified it by using the length function. We did the same with a list containing elements of the same type, as well as list containing elements of different type. And we also concluded by creating a list of elements of different type that a list is heterogeneous in nature. We realized that, or we proved the fact that lists are sequential in nature, and therefore they can be indexed using both positive integers as well as negative integers. Then we moved on to slicing, where we not only looked at the general syntax, and we concluded that all the 3 values, the start index, the stop index, and step size, all of them are optional, but we also looked at many examples, right, of how we can use the slicing operation to extract various portions of the list without altering the original list itself. So when we perform a slice operation, the original list, remember, never gets altered, right? So I hope you found this video useful. Please feel free to comment your doubts in the section given below. And if you found it really useful, you can press the like button, and you can subscribe to our channel for more such videos. Thank you for your patience, and I'll see you in the next one. Bye-bye.